Up, fellow nerds? There is some good stuff in this next video. Hey, there's some good stuff in here. So we're still in Unit 2. That's what's up. We're now on Packet 2, talking about z-scores. Z-scores is a I can't talk. Big deal. Big deal in statistics. So I'm going to kind of introduce you to z-scores in the first part of this packet. We're going to get caught up to first hour in this video. Let's hope this doesn't take forever. Let's go. So here are some results of a random sample of 20 Chapter 1 tests along with a dot plot. Ooh, that's nice. And summary stats. So there's everyone's scores. There's a dot plot. And then there's the mean, standard deviation, minimum Q1, median Q3, max. Great, but whatever. So Biff scored a 65. Ooh, yikes, Biff. There's Biff right. No, one of these is Biff. Biff's right there. Okay, so we need to figure out Biff's percentile. Remember, a percentile is everyone that is just as even with you and below. So we need to count up all the data points that are also at 65 and below. So it looks like there is 1, 2, 3 data points that are at or below Biff. Out of a potential, my goodness, 20 data points. So there is 3 total out of 20, which do a little beep bop boop bop, calculating on the calculator. You get 0.15. Yay, Biff. That's the 15th percentile. Remember, that does not mean Biff got a 15%. He got a 65. He passed, and that's good. But he's the 15th percentile. So what does that mean? Biff did better or equal to 15% of everyone who also took that test. So he just did as good or better than 15% of the people who took that test. Way to go, Biff. Now, follow-up questions. Was Biff above or below the mean? Now, you can figure that out probably 2 different ways. One, we know the mean is 80. He got a 65. So, therefore, Biff was below. Okay, Biff is below the mean. Another way you could probably figure that out is the 50th percentile would be the median. We don't really know the mean, but 50th percentile is the median. If 50th, I don't want to sound like I'm saying 15th. If 50th 50 percentile is the median. Mean, hopefully, the average is hopefully somewhere near that. At the 15th percentile, you're probably below average. So, was Biff above or below the mean? Biff was below. Okay. By how many points? So, how many points below the mean was he? Well, if he's at 65 and the average is 80, we got to figure out how many points below the mean is Biff. Well, if you take 65, which is what Biff just did, and subtract off my mean, 65 minus 80 is negative 15. See how you got a negative number there? Nice. So Biff is 15 points below the mean. So he's 15 points below the mean. All right, Biff. I see you. By how many standard deviations? We got to figure out if he's 15 points below the mean. How many total standard deviations is that? This one's kind of a hard one. Okay. Usually, if I was in class, we'd sit there and ponder this for like 40 minutes and flip a couple desks. But we don't got time for that, okay? So how many standard deviations is he below the mean? So here's what you're going to do. We just did a difference here to say he's 15 points below. So what we're going to do is we're going to take that difference and divide by standard deviations, okay? So the difference that we got is he was 15 points below, yeah? Yeah. And divide by whatever a standard deviation is. Well, according to this problem, standard deviation is 10. if we take that difference and we divide by a standard deviation, 15 divided by 10 for our specific numbers, that is 1.5, which means Biff is 1.5 standard deviations, which I'm going to write as just SD, below the mean. Wow. Okay, Biff. Good to know. Fun activity. That was great. Let's do more. Kind of a little bit beating a dead horse, but let's do it anyways. We're kind of do the same idea, but now we're going to deal with Marty. For those of you that understand the reference, good on you, Biff and Marty. Those of you that don't know the reference, get off TikTok and watch more movies. Moving on. Marty scored in 88. What is Marty's percentile? All right, so we got to count up how many data points are at 88 or below, okay? So if 88 is right here, we got to count up how many data points are also there and below. Oh my God, here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I don't know why I turned that to a song. There are 16 data points that are at or below Marty out of a potential 20. And as everyone should know, 16 divided by 20 is 0.80. So what does that mean? Our friend Marty here is at the 80th percentile. I ran out of room, so I stopped writing. Marty's at the 80th percentile. Remember, Marty scored an 88. That is his actual score. His percentile is the 80th percentile. So he is better than or equal to 80% of the people that took the test. Way to go, Marty. Was Marty above or below the mean? All right. Well, if Marty is at an 88 and the average is an 80, I'm going to say he is above the mean. Marty is above the mean. Fun. Good. Okay. So he's above the mean. By how many points? Oh my goodness. So if Marty scored an 88 and the average is an 80, we're going to take that difference, 88 minus 80, and that is 8. That is 8 points above the mean. Way to go, Marty. By how many standard deviations? So what we're going to do is we're going to take that difference we just found, right there, and we're going to divide by a standard deviation. We're going to take that difference and divide by a standard deviation. So you take 8 divided by 10. Ooh, that's a tough one. That is 0.8. So Marty is 0.8 standard deviations above the mean. Yay! Way to go, Marty. By the way, if you still don't understand the reference, Marty and Biff are characters in Back to the Future series. It's fantastic. Watch the movies after you finish these videos. Okay. Believe it or not, what we just did up here is we calculated something called a z-score. Okay. We calculated a z-score for Biff, and we're also doing z-scores for Marty at the same time. Just some slight changes on how we handled some of the numbers, okay? A z-score is defined as the number of standard deviations above or below the mean, okay? So this is an introduction to the idea of z-score, and man, oh man, are we going to build on it. So a z-score is the number of standard deviations above or below the mean. This was so good of a definition, I put it in bold, and now I just put 3 stars next to it, and you should too. Okay. What is the formula for calculating a z-score? You can do it 2 different ways. I'm going to show you one, and I'll put another one right next to it. What it is a fraction. You're going to take whatever value you're interested in. So maybe Marty's 88, Biff's 65%. That would be the value. And you're going to subtract off the mean, okay? To calculate a z-score, take whatever data point you're interested in, that value, subtract off the mean, and then divide by a standard deviation. And that will give you a z-score. Wow, okay? Another way people say z-scores is they say take the observed. Like what did you see happening? I observed that Marty scored an 88. okay? And then you're going to subtract off, instead of mean, a synonym for that would be the expected. When you're talking about what you expect to happen, that is a mean. So when you take an AP Gov quiz or something, I don't know, whatever class, and they're like, oh my God, the class average was a 40%. What do you expect to happen? You probably got around a 40% if that's what the class average is, right? Right, fun. But take your observed minus expected and divide by your standard deviation, okay? I abbreviated standard deviation 2 different ways. That's fun, okay? That is the calculation for a z-score. This is like never, ever, ever going away this entire school year, so buckle up. Goldie scored a 98 on Chapter 1 test. Find and interpret the z-score. Okay. Goldie, by the way, is another character in Back to the Future. I believe Goldie is the character that ends up being the mayor. There you go. Movie fun for you. So, to calculate Goldie's z-score, we need to start with Goldie's observed value, or Goldie's value. Goldie scored a 98. What a nerd. Okay, 98. We're going to subtract off the mean, the average. The average was, the expected, it's all the way up there up top. It's an 80. Woo! So we're going to do 98 minus 80. We're going to do that first in a calculator and then divide by our standard deviation, which is 10. 98 minus 80, 18. 18 divided by 10, you get 1.8. Nice. So what is that? That is Goldie was 1.8 standard deviations above the mean. That is an excellent little question. This type of question, number 6 here, is something I ask on our quiz all the time. And people always get it wrong, and it drives me crazy. They give you information, they're like, hey, find and interpret the z-score. This is finding the z-score. Just calculate z, and you're done. And interpret, you just have to tell me, what does this number mean? What does a 1.8 mean? A 1.8 for a z-score means Goldie was 1.8 standard deviations above the mean. That's what that means. And that's all you have to do. Great. I'm not going to trail on forever on this because we're on video, but what do z-scores allow us to do? We're going to expand on this heavily later in this packet. What it's going to allow us to do is it's going to allow us to compare data values, right? It's going to allow us to compare data values, especially ones that might be hard to compare, okay? This one's pretty easy with Marty, Biff, and Goldie. Since they all took the exact same test, it's very, very easy to say who did the best. Well, since Goldie got a 98, obviously Goldie did the best, and then it was Marty, and then it was Biff who was, I mean, yeah, right? By the way, you'll see, okay? So z-scores allow us to compare things. When the thing we're comparing, like we're comparing how everyone did on the exact same test, z-scores aren't really necessary, right? If you want to ask someone else, hey, what's your grade in AP Stats right now? And like, I got this. That's a very easy thing to compare. Super easy to compare. Whoever's higher is quote unquote better, right? What it's going to allow us to do is it's going to allow us to compare data values that might not be as easy to compare. For example, very popular where we live is the ACT. Most students that are going to college, they take the ACT, they get a score, right? Not as popular in the Midwest is the SAT. So it tries to accomplish the exact same thing. It's a completely different score. So let's say you take the ACT, your friend takes the SAT, and you're trying to figure out who did better. That's what a z-score is going to allow us to do. You could calculate a z-score for your ACT. Your friend can calculate their z-score for the SAT. And once you have z-scores, you can compare those directly to figure out who is better, okay? And we'll do that more later in this packet. So if you're like, I don't really understand what they're for, just wait, because we'll have problems on that. All right, let's go to the next page. I'm going to give you a little bit of task to do, and that's how this video is going to end. Oh, no, right? So what we're going to do is we're going to kind of look at, we're going to use that same data set we've been dealing with, those test scores that Marty, Biff, and Goldie were dealing with. And we're going to look at what effect does a z-score have on things. Like when you're calculating a z-score, what does it do? And that's what I'm going to kind of leave you with. And hopefully I'll be back on Friday and we'll pick it up. So again, a z-score, you take your value, subtract the mean, divided by a standard deviation. So the first thing we're going to look at is we're going to take each individual score and subtract the mean, subtract the average, okay? So if I have these scores, there's all the scores from the test, blah, blah, blah. That's row 1. What I need you to do, and I'm not going to show you on this video, is I need you to take each individual score, like 61, and subtract 80, okay? Take 61 and subtract 80. 61 minus 80 is negative 19. Fun. Then go to the next cell. There's 65. Take 65 minus 80. You don't need to write out all the subtractions. I'm just doing this so you can see. 65 minus 80. That's a tough one. Use a little calculator. Beep, bop, boop, bop. You get negative 15. Okay? And you're going to figure out all of those numbers in the second row. Just take each of the top, subtract 80, 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 subtract 80. Okay. That'll be your second row. Here's what I need you to do. You're going to take the original scores, dot plot for score. I want you to make a dot plot here on this graph. So like you're going to take the data point 61 and be like, oh my God, there's 61. Boop, there's a dot. Take that 65. Let's see, that's 60, 62, 64. So 65 will be right there. Boop, and there's another 65. Boop, boop. I want you to make the dot plot of row 1 over here. Yay! And then once you finish the second row, I want you to make the dot plot for row 2 over here. Yay! Okay. When you do that, once you're done, I want you to compare the visual shape of it. Compare this shape to this shape. Are they the same or are they different? How? Compare their center. Are they the same? Are they different? How? The variability, which remember that means spread. See if the spread, same, different, how, okay? See what effect, because right now all you've done is the top part of that part of the equation. See what effect, when you're doing a z-score, what effect does that have on our data? And if you could get to that point, that should be good enough, and I'll take things from there, okay? That's all I have as far as our notes. Then hopefully my children eat their fruits and veggies and I can return to school. All right, that's it. I'm going to go upload this now.